In this video, we are going to refresh some skills for working with complex numbers. Our objective is to be able to add, subtract, and multiply complex numbers. Notice that normally we would add, subtract, multiply, and divide. We are not going to divide. That gets into a lot of details of algebra that we don't end up using when we apply algebra to real-life context. So let's take a look at what are complex numbers. So complex numbers have a real and an imaginary part. They take on the format of A, which is the real part, plus BI. And this lowercase I is the letter that's used for the imaginary part. Because they have this imaginary part, they do not show up on the graph. Which is why we need to have a little bit of proficiency in working with them by hand so that we can solve things with them. They really are a construct of algebra, and that's how we get things that are imaginary. We don't see them in real life, but we can take real life examples and end up with an imaginary solution. And that is telling us then that it's not going to work out in reality, and yet on paper, the mathematics can be solved. So when we look at this I, what does this I represent? I represents the square root of -1. And so since when we try to take square root of -1 on a calculator, we get an error message that the calculator is not overly helpful with these. However, doing the algebra can be helpful in solving real life problems, because when you square I, you get back to the real numbers, because when you square root, they cancel, and so I squared is -1. And so if we would have reason to square the answer, then we're back in the real number system. We have something that makes sense. So this is literally a tool, and we're going to look at some problems where we're working with the imaginary and complex numbers. We're not going to do all of these examples in this video, but a couple. And so the first example is asking us to take the square root of a negative number. And if we just try that on our calculator, we get an error message. So up here, it says what happens when you take the square root of a negative number. You get an error message. And so our workaround is to use I. So I don't always write out all the math, but I want you to see the math so that you understand where the answer is coming from. So what I would do is, first off, I would rewrite this as square root of -1 times square root of 36. And I could see that if I would multiply together, I would have square root -36, which is the original problem. But splitting it up in these two, I know the square root of 36 is literally 6, and the square root of -1 is how we defined I. So square root of -1 is I, square root of 36 is 6, and then we rewrite this in a standard form with the number first and the I, the symbol for square root -1 second. So square root of -36, instead of just saying it's an error, we get to say that this is equivalent to 6I. All right, so then our objectives were to be able to add, subtract, multiply. We skipped divide. So this next one is add. And so the key is to add like terms. And so I add the real parts. So the real parts are 3 and 7, and I add them together, and I have 10. And I add the imaginary parts. So I have the 5i, and keep the sign with it, the -3i, and I add them together, and I have +2i. And WebAssign is totally going to care on how you write this, because complex numbers are always a plus bi, and so you have to have the real part first, and then you have to have the imaginary part last. And so when you go to type your answers, it's important that you have them formatted correctly. All right, so that was add. Next, we're going to subtract. And with subtract, you subtract like terms. This one can be a little bit trickier, but we can work through it. So my real part is 2 minus 1. So 2 minus 1 is indeed 1. Then I look at my imaginary part, so I have negative 6i minus negative 8i. I'm going to write that over here to the side. So I have negative 6i minus, because it's subtraction, and then I have negative 8i. So we can either do on our calculator, negative 6 subtract negative 8, or we can make the two negatives a positive and have negative 6 plus 8. And either way, we'll end up with 2, and so that represents plus 2i. Number 4, well, this one is directly out of our notes, so I squared is negative 1. And that's because if you do I, which is square root negative 1, and you square it, square root and squared cancel, and so that is how you get that answer. All right, number 5. This one is a multiply, and so multiply is a little bit more work. And the process that we're going to use is that FOIL acronym that we had used to check factoring. So FOIL just helps us to get all the parts, so we're going to multiply the first terms together. So 1 times negative 3 is negative 3. The outer terms together, so 1 times 2i is plus 2i. The inner terms together, so 5 times negative 3i, and that would be negative 15, and there's an I. And the last terms together, so 5 times 2 is 10. And we have I times I, which is I squared. The middle terms are clearly like terms, so I can simplify a little bit immediately. So I have negative 3, adding 2 plus a negative 15 would give me minus 13i. But I have to remember that I squared is negative 1. So this one is really 10 times negative 1, because I squared is negative 1. And if I multiply them, I then have minus 10. Now, I have a real part at the beginning and a real part at the end. I must combine those like terms, and so I have negative 13 minus 13i. And I do have to do all of that work because my answer has to be an imaginary number, or excuse me, a complex number, having both a real and imaginary part. So when I added, I got a complex number. When I subtracted, I got a complex number. When I multiply, I have to land on a complex number. The same would be true if I was dividing, but we're not. So the remaining examples are in a separate video for you, and you can practice them on your own, check your work in the video, and we're just using a lot of skills that we already had with combining like terms, and with FOIL, we're adding in the little bit that I squared is negative 1, and so we have to do that substitution to complete the problem.